I'm going to show you how to convert 5 halves to 2.5 using a model. And then afterwards, I'm going to show you the same thing, but we're going to do it algebraically. In other words, we're going to show this with a picture and show it without a picture. The first thing you're going to do is you're going to draw the rectangles. So remember, your denominator tells you how many slices you're going to cut this into. So since my denominator is 2, I'm going to cut it into 2 slices. And if I were to shade these two in, you can see I have 2 halves that are shaded so far, and need a total of 5 halves shaded. So I'm going to keep adding halves until I get to 5. So you can see here that 5 halves breaks up into these 3 parts. 2 halves plus another 2 halves plus 1 more half. That's a total of 5 halves. So 5 halves is the same thing as 2 halves plus 2 halves plus 1 half. And my goal is to convert 5 halves, and I'm going to show through this model how it's going to change to 2.5. Now, when you look at this, 2 halves, you can see here, is the same thing as just one fully shaded rectangle and another fully shaded rectangle. So again, you can see that this 2 halves is the same thing as just one rectangle. That's the same idea here. And the 1 half is still the same thing as a half. So this is equivalent to just saying 1 plus 1 plus a half. And then when you combine these two together, you're going to get 2. And then your 1 half left over, bring that down, and you get 2.5. So now from this visual, you can see 5 halves is the same thing as 2.5. And then once you have your model created with your labels, the easy part is, or the hard part is done. Then the algebraic part is basically just take out the pictures and only write down the numbers. So you can see I have 5 halves breaks up into 2 halves plus 2 halves plus 1 half. So then again, this is basically pulling it from here. And then you can see that this is the same thing as just saying 1 plus 1 plus a half. So I wrote this down as well without the pictures. And then you can see that when you add the ones, you get 2 and bring down the 1 half. So you can see 5 halves is the same as 2.5. So again, you can see the model has the picture. The algebraic portion does not have the pictures. And one thing I forgot to mention, notice that we were converting a improper fraction, so an improper fraction, to a mixed number. And in this next example, we're going to convert a mixed number to an improper fraction. So similar to the last problem, right? We're going to draw our model. So 1 is a whole number, so 1 whole rectangle is that. And then my 1 half is 1 out of 2 shaded. So this 1.5 is represented here. And I write down my labels, 1 plus 1 half. And keep in mind that we're saying 1.5 is the same thing as just saying 1 plus 1 half. So adding these together gives us back this original problem there. And also don't forget, we're trying to show how this is the same thing as 3 halves. So since this is already cut into 2 slices, I know my next step, I'm going to do the same thing. I'm going to cut everything into halves so I can see how many halves make up this problem here. And now you can see that when I cut this in half, 1 is the same thing as 2 halves, and that stays the same as 1 half. So now we have 2 halves plus 1 half is the same thing as 1 plus 1 half. And finally, you can see when you combine these together, we have 1, 2, 3 halves. So we just showed 1.5 is the same thing as 3 halves. And then for the algebraic portion, all you got to do is eliminate the pictures and then bring down just the numbers. So 1.5 is the same as 1 plus 1 half. And then remember, the 1 rectangle is the same thing. So 1 whole is the same as 2 halves. So 1 whole is the same as 2 halves. I bring down my other half. And now I have 2 halves plus 1 half is the same as the 1 plus 1 half. And then lastly, right, when you add 2 halves and 1 half, you can see we have a total of 3 halves. So 2 halves plus 1 half is 3 halves. And now we can see 1.5 is the same as 3 halves.